test out their application without having an actual Android device in your hand. So you can just code it and then test it out on your system that how it is working. So this is necessary. This users feature is necessary when you're using it inside an emulator. Yeah, so simple enough. We'll. So I'll be talking about generally about how engines are initialized. I will not get into and engine and specifically. So the first thing that you need, what is the screen size? Are you playing it on a 1024 by 768? Are you playing it on a 720 by what is 720 by 800, I guess? So then you're playing on an 800 by 480. What is the size of the screen where your game will be displayed? So the first thing, simple, we defined the width and the height, and we defined a camera. You need a camera to actually see what's happening in the game. A camera is basically the viewport where you will see. So you can create a big level and the camera will be only focused on some part of it. And then you can move the camera around. So it's basically like you're showing the some part of the game and then after some time you're showing the other part of the game. This is used when you see player running from one part to the other and you can move around your camera in a free fly. So cameras are very important because you need to show what is happening on the screen. So we define just the camera height and width and a camera itself. So simple statement, we just write camera and we define a new camera object. The 00 are the coordinates, x coordinate and the y coordinate, and then the camera width and the height that we set. So in AND engine, everything starts from the topmost left corner. So any object 00 would not be at the center, but would be at the top left corner. So just 00 and camera width and camera height. That means I am placing a camera that is big enough to show my resolution of the screen. Since it was 480 by 800, so from 0 to 480 would be the height or the width. That depends. Are you playing it landscape? Are you playing it portrait? So that might change. Yeah, so coming to the next one. These are the engine options. As I told you what engine options are, this is where the easiest jobs comes in for the game designers and developers, that all you need to do is just pass on some variables and your engine is initialized. You don't have to worry what's happening behind the engine. You don't have to go about looking into the architecture where what is happening, where is it going, is there a problem in the engine or something. So all you need to do is just pass few parameters and that's all. So the first parameter is full screen. Do you want to play it full screen? Yes, you want to play it full screen. So just a true. Then, do you want to play it portrait or landscape? And do you want to make it fixed so that even if the player turns his phone, it does not changes? There are games that change on runtime, but usually it is always better to develop on one side because either your game would be a side scroller, either your game would be a first person shooter. So you can decide. So there are other options there you can see. Then the next thing is ratio resolution policy. This is one thing that you will see. It's a very common problem that if I try to play a game on an Android phone and then the same game on an Android tablet with a larger screen, the images pixelate. They get stretched off because these images have been created for a resolution that is smaller than the one we are using. Resolution is basically number of pixels across the screen in the horizontal and the vertical. So just imagine a 7-inch tablet and a 4-inch screen. If these they can have the same resolution, but these pixels will be spaced differently. How this is done is like I'll tell you. If you have a bigger screen, the number of pixels remain same, but they have to be arranged in the whole space. So they will space out. But on a smaller screen, you have less space, but you have more number of pixels. So it will appear more, as in it will not pixelate because every pixel would be near to the other pixel. But on a larger screen, what will happen? They will space out, and you will start seeing edges, and you will start seeing fractures in the image. So that is how this is done. So how do we create a game that is compatible with all the screens? The answer is there is not a specific answer to this question. People are finding answers to this. But the best way is to create different images for that, sizes images. So if it's a big screen, create a big image for it. If it's small screen, create a small screen. In Android, there is a feature that you can switch images depending upon the screen itself. So it is not that you have to write code for that. The moment you use the other as an other image, a screen that is larger, the new image will be placed rather than the smaller one. So this is ratio resolution policy. Now, what happens if I wrote 720 by 480 by 800, and my device here, this one runs on a 1024 by 768. For example, I'm not sure about it, but it runs on that. So just imagine if it's the ratio between these width and the height is different on both the devices. So it will appear like this, a band, some amount of band will appear on upper side of the right side or the left side, depending upon the ratio. Because what I'm trying to do is, I'm trying to scale up 800 by 480, and I'm trying to bring it to 1024 by 768. So just imagine it will go like this, and then squeeze it up. So basically what I'm trying to do is, I'm keeping the ratio same, but I'm trying to stretch it out. If I don't do this, what will happen is either my width would be larger than my height, and it will not appear nice to you. So my height would be more than the width because I'm stretching it one way. I'm not stretching it two way. So that's why this is important. This you will only understand when you know how screen resolution work and how do you develop for multiple screens. Then the simplest options after this. So I've already told you about the parameters that you have to pass. Yeah, so simplest option that you need music and you need sound. So all you need to do is get audio option, set needs music, true, and needs sound. So the moment you say this, it initializes its own sound engine, and you all need all that you have to do is just pass the sound file. It will manage everything, all the memory management, everything is already done by the engine. All you need to do is when to play the sound, when to stop the sound. That's all you need to do. So the problem is, I had defined it as constant 800 by 480. What if I don't want it constant? I want it to determine itself when the device is changed. When the screen is bigger, it should define its own resolution and completely fill the screen. Because I told you, if I play that same game, there will be a black bars to fill it up so that it gets mashed. So but I don't want that. I want a real time when the screen is as large as a Google TV. I want to play the game there also, and I don't want the black bars to appear there. So what I'll try to do is I'll try to find the size of the screen before I initialize all those variables. So this is one method I wrote that you can find out. It's simple enough. You can find out the screen size before and then initialize camera width and height to that. This only works on a target API of 13 plus. 13 plus is Honeycomb. You can only use this on Honeycomb plus Android versions. Then a similar one, if you want to use it before, you can write another code to determine the size. So this is very useful if you want to develop for different screens. Yeah, so simple. Now we'll try to create the scene. There are two scenes, splash scene and game scene. So I'm just shifting the scenes from, I'll be showing in the I'll be just showing the game scene. We'll not be talking about splash screen. These are just images that keep on changing after some time. So that is not important. What is important is the main game scene. What will happen inside the game? The game is, how many of you actually played Bubble Burst before? On Android. Bubble Burst. Never heard of a game called Bubble Burst? Where you have to just burst the bubbles, that's all. It's a very silly game. You just need to burst the bubbles, that's it. So what you can do is, I'll try to show this. Okay. This is, I'll try to run it on my device and show you what happens. I don't know how many you can see it from here. So it won't come there. Android does not have that. Do is all you need to do is just burst the bubble. It's hard to do that because I've written the code in a way that it's hard to do that. So you can create this game in less than 3 hours. That's it. Your first game in just 3 hours, under 3 hours. Yeah. So we just have 13 minutes left. I'll just quickly scroll and come to a point where I need to explain you something. Okay. So there is something called as sprites. If you've heard about sprites, or sprites is not related, generally related to as in sprites is a common word we'll be using in whenever you go to a game industry. Sprites are very common when a 2D game is being developed. So sprites are nothing but just images, just simple plain images. Just imagine you open Paint and you draw a face. You draw a face and you save it as a image file. And you want that image file as in you want that smiling face in your game. You can that is as simple as sprites, right? So, but what we do is in a game engine, if imagine if I have 10,000 I have 10,000 sprites like these. I have trees, I have water, I have players, I have enemies, I have tanks. Just imagine I have all these images created by my designer and he gives me 10,000 files. Okay, here is it, create your game. So just imagine if I start loading the engine with these games, as in with these images. The engine will take almost a day to load all of them and then won't be able to display all of them together also. That is where Texture Atlas come into play. Texture Atlas is something where it is kind of an atlas, as in your normal atlas, where you place in all the images in one container. Just imagine you have a poster. I give you a poster, a big size A4 poster, and tell you to draw everything that your game needs on it. Draw your player, draw your trees, draw water, draw anything you want. Then I'm not going to take those images. I'm going to take that sheet from you and then pull out those images whenever required. Does it make sense? That rather than putting 10,000 images, put the 10,000 images in one image and pull it up whenever required. So that is where Texture Atlas come into play. An example of Texture Atlas is this, where every texture that is needed in the game is being placed. This is being placed in one sheet, and one sheet is being given to the engine. The engine is smart enough to pick up what is required when. How this works is on the right side you see a fireball. Just imagine if I cover the whole sheet and I just show you the first frame of box around that fire. Just imagine that. Imagine if I hide everything and there is a small box around that first fireball and I try to move that box all around. And the only thing you can see is through the box. Everything is covered, but you can only see through the box. So just imagine if I move it very quickly, it will become an animation. If I tell you to close your eyes and just see one point and try to move your face, you will imagine that the object is moving. It's the same thing that I'm showing you a small box and I'm trying to move that box all around. That is where sprites come in play. So just imagine creating an animation, showing images, removing images again and again. I need to create an animation where one there is a fireball. So I'll put 10 images and show one, then again, then the other, then the other, then the other. Imagine removing and showing those images. It will be painful. So it's better to have one sheet and scroll through the sheet in that speed that you imagine that there's only one animation. That is called animation sprites and texture atlas. For this game, there are basically only three images you require. One is the splash screen, one is the background where you'll play where the bubbles will appear, and the bubble itself. So these are created in Photoshop. You can create it in any program that you like, you want to develop. So you can create it on GIMP, you can create it on Paint.net, or even on Paint if you are that good. So anybody can create this on Paint. Anybody? Have you ever tried creating something like this on Paint? Yeah, so you can create bubbles, obviously. Yeah, so I'll not get into this how to load the images. Just the important point is uh, just a second. Yeah, so this is I'm only giving you tips how engines work. This is a very common mathematical formula, you can say, or something that is used whenever an object has to be centered and the coordinate lies towards the left. Can anybody first answer how this can be done? I'm removing the screen. Don't see the screen. There's the previous slide. Okay. Imagine the coordinate system has its center at the topmost left, and there is a center of the screen. I have to place that object in the center of the screen. Can anybody answer this question? So anybody who answers this question, wait, can give me the x coordinate of that image and the y coordinate. Exactly, and y coordinate. I hope all of you got the question. It was amount by I'm asking you, there is a center of the screen also. So you have to place that image on the center of the screen. There is a center of the image and there is a center of the screen also. You already know the concept. Somebody else, it's Matt, you also know that. You also know game programming. Be loud.
Width by 2 minus height by 2.
Simple, just not complicated. Okay, the question is, you have a screen that has a center. You have an image that has a center at the top left of that image. Now you have to place the center of the image on the center of the screen. Yes? Be a bit loud.
First we'll get the screen size, the width and the height, and
Okay.
then we'll put the center of the screen.
Give me the x coordinate, that's it.
Like width by 2 and height by 2.
So what is, no, that's already done now. Yeah, that's it. That's also not exactly right, but it's, yeah, we can give it. Yeah, so come on the stage. So it's basically the width, right? So you said width by 2, right? Oh yeah, then it's correct. So he's correct. So he gets a Google I/O 2012 extended T-shirt. So it's a very simple thing that you will always see when you are developing games. Even 3D games or 2D games, you will see. See, camera width by 2 minus the width of the image. So I'm trying to center the bubble on the screen, and I'm trying to center. So what I do is I calculate the width of the screen. Then I say, okay, I have the center now for the screen. Now I place that image, the left corner of that image, on that center. Then I subtract the half the width of that. Does it make sense? Easy enough. Yeah, so that is where you need maths, and this is just the beginning of it. Another thing I'll talk about is physics very quickly. So, how many of you like physics? What in physics do you like? Do you like calculating as in, do you just like, what were they? I forgot. The three equations of motion? Yeah? Yeah, so that's the only thing you like, or do you like more complicated stuff? How many of you like quantum physics? You don't need that. Don't worry, you don't need that. You don't need that in game programming. I don't know. I haven't seen that anywhere. Anyway, so physics is basically what we'll try to do is there are in a game engine, especially in AND engine, I'm talking about AND engine, there are two types of physics. One, the real world physics, where you calculate the gravity, you calculate every forces acting on an object. And then there is you can call the unreal world physics, where you define your own physics, where you define the velocity, the acceleration yourself. So the Unreal part of it is very easy to use. It is directly there in an engine. But if you want to go about creating real-time physics, okay, anybody can give me a real-time physics example in a game. Every game has it, but still, Angry Birds. I was looking for Angry Birds. Angry Birds, when the bird actually hits that structure, the structure falls real time in physics, as in calculating the physics where the force has been applied. So that is called a real world physics. For the unreal world physics, you can just define the velocity, the acceleration. Okay, I want to bring that from x coordinate to y coordinate at an acceleration of 5 units per second. So don't write 5 meters per second. It'll just go off. So just it's like units per second. So I just want that. So that can be done by an unreal physics kind of stuff. Here I'll show you an example. What I have done is the bubble is moving. So I've given a velocity, a simple velocity, set velocity in the x and the y coordinate, and velocity is given as 10. It's an integer given as 10, so it is moving diagonally at 10 and 10 units per second. Then the simplest AI I'm going to show you is collision detection. What if a bubble moves out of the screen? How do you calculate that? The same thing that we were solving is used for that. What we do is we just check. It's the simplest collision direction code you will ever see in your life. It says if the x coordinate of the bubble is greater than the width of the camera minus the width of the bubble, that means on the edge of the screen, then reverse the velocity. Simple. Similarly, in the y and the x direction, reverse the velocity depending upon the coordinates. This is the simplest if statements you've seen in game programming. I'm telling you. And what happens is, done? I have 2 minutes to go. So what I'll show is I'll like to talk about game loop that I started with. I'll show you an example of game loop. This is a game loop. In Android, it is different from other platforms. It is different. But what it is happening is inside a game, there is something called as a tick. It's like ticking. It's like the clock ticking every second, or every second there is a tick. And what happens is every variable is updated. For instance, just imagine a clock going on in a game, and you calculate the simplest would be just you calculate the time of the day. In some games, there are options that the time of the game changes. Have you played GTA or games like that? Have you heard about them? You see that the game goes on, and the timing keeps on changing. The weather is changing, everything is changing. So what is happening is it is not actually changing because it's like a real life kind of stuff. What is happening is at every tick, it calculates a random variable, picks up that random variable, and sees that okay, it compares those values, and if a threshold is maintained, it will change it. It's simple enough. At every tick, a logic is performed. I was performing the if else logic for collision detection at every tick. So what I was trying to do is I was trying to get x and y coordinate of the bubble at every second. At every second, I was checking that. It's a going on for, while loop. It keeps on going, and it keeps on checking that okay, is the x coordinate greater than this, or is the y coordinate greater than this? If yes, do this. Else, don't do anything. Else, keep on repeating whatever it was doing. So the thing is, this is where game loops comes in. So for game loops, I'll give you an example. If I have, I don't have time. I have 28 seconds left. So, so the thing is, I'll be sharing these resources. You can go ahead and create your own game out of it. Then, And Engine has a lot of examples. And Engine has examples, a list of examples which you can see. Yeah, so you can see there are a lot of examples in And Engine. So you can copy the code if you want and then play around. So I guess my time is over. Thank you, all of you. And if you have any doubts about Game Engine and all, I'll give you my contact. So you can contact me at my email address, or you can just ping me on Google Plus. And if anybody is interested in developing a game engine, uh, just contact me, because even I am interested and I need people. I cannot do it alone, right? So anybody who's interested in developing a game engine from scratch, please contact me. Thank you, all of you.
I'm here to see you all guys, and it's so good. I'm feeling like this event is pretty happy and pretty good for me also. And this is the lunchtime now, so you can go and have lunch, fill your stomach, and if you get in, I should say special thanks to this guy Karthik and Jayanthan, because they have just taken an initiative to have this GDG event in Chennai, and this is pretty much good for the Google also. And that's it. Thank you so much.
Thank you, Bhumika, for having this time, right? And we should all thank Google and Bhumika so that they have spent their time to come here down, watch the entire program, right? And I'm totally glad she has a very positive note on the entire subject that we are working on, right? And I want a good round of applause for yourself. Okay. Come on, yeah, that game is over. People keep yelling after that. Okay. This was the Google's first tweet on twitter.com, the official tweet. Any idea what it says? Wow. It's written in binary, which says, I am feeling lucky. Isn't that interesting? Okay, these are little fun facts that I wanted to share, right? Okay, next thing. Okay, I want you to pay a little more attention here. Wow. Okay. The top 5 people on Google Plus, right? And you can see the number of followers in circles. And you see the number 1, a person from Facebook, right? Okay, a person sitting at Facebook has an account here, profile. And interestingly, you can see he's having the most number, probably he's very active here. Yeah? Okay, that's pretty good, interesting one. To take a little further, ages ago, this was Google's first storage, which was made out of Lego toys. Isn't that interesting? Yes? Okay. Taking a little further. Okay, this is very interesting because the target of Google's IPO on April 29, 2004 is somewhat strange number and is equivalent to the mathematical constant E in billions, which is equal to pi. Right? 22 by 7. You get a value, right? No? Then I'm wrong. Okay. It is equivalent to the mathematical constant E. And they say that E is the last alphabet of Google. Google. Interesting. Okay. The most used country, like, which countries are the most active Google users? Starts from Google. Come on, man. We have to compete that place, isn't it? Next time, the percentage mark should be here. Yes? Okay. And I'm happy that we all have been getting a very good tweets and retweets that are happening on Twitter. How many contributors here? Okay. End of session, I'll be giving some freebies for this. Right? Okay. So first starts with US, second India. What is the third? Brazil. Okay, you can have a look. I'm very weak at geography. Going further, I get reminded of a very interesting advertisement on the Hindu paper, okay? I saw a huge, world world map. Bottom it says, it's a very big map, no? It's a satellite picture, if I'm not wrong, right? And the bottom, it's a small text underneath. It says, Are you a geography teacher? We have a job for you. Google Earth. Wow, that's pretty interesting, isn't it? Okay. Let me jump here. Okay. Probably we should be seeing that post session. Right? Okay. How many of you know that Google does not use lawn mowers to cut their grasses in their official California headquarters? Google does not use lawn mowers, no, which cuts grasses on their official California headquarters. You know why? Okay, I'll tell you the alternative that they use. Very interesting, okay? Google rents 200 goats and they leave it to graze. No, they go eat all the grasses. Isn't that very interesting? And Google is totally eco-friendly, which means they have a complete solar end panel. Entire office runs on solar. Right? If they had one of the biggest offices in India, I'm pretty sure it'll be very good for them. Because half the time we don't have current. Right? Rest half the time it's night time. So power is not there. Okay. Post lunch, we'll be having one session initiated by Ajit. Right? In that, we'll be seeing about Android hacking, which means what are the security implications that would generally be there in any Android architecture and how can we fix it, right? Next thing, how is it relevant on other platforms too? iOS, Symbian, whatever, right? He'll give a brief overview and best practices that to be followed on majorly on all kind of platforms. Yes? And we also have a very interesting demo to be presented to you by Mr. Prem, right? Which is all post-lunch session, right? And you will also have a very interesting poster there on the corner, right? This poster will be put outside post the lunch. Okay, the interesting part about this poster is you see a love icon in the between. After that, you see an Android bot, right? And here it says, stand here. What does it mean? Okay, when you go stand, people can take a photo of you, says, I love Android. And the interesting part is, it's just not for one person to stand. It can be even 10 people or 5 people to stand. Which means, we love Android. Yes? Okay, how many of you are Android users? Pretty good, man. How many of you are developers? Okay. No, not now. He's creating some infusions. Yeah? Lunch ready? Okay. We'll slowly move, right? We don't want to rush around. We'll slowly move. And this time we'll get back sharp in 1 hour. Yes? Sir, காலேஜ்லயே எங்களுக்கு 1 hour கொடுக்குறாங்க நீங்க என்ன சார்? Right? Okay, we'll get back in 1 hour. We have very interesting piece of sessions to be followed then after. So please be on time, right? Thank you so much.